With good feature representation, now we will go into more details about developing uh, an accurate multimedia system. So with good feature representation, we also need some advanced technology to build an efficient multimedia analysis system. And now we need machine learning technology. We know that machine learning technology has has been developed in the last 2 decades, and it largely improved the performance and the feasibility and the possibility of many applications or and many technology. So in the following slides, we will briefly introduce machine learning technology for content analysis. Uh, I I write down a brief introduction here because actually machine learning can be offered for the whole semester, and we just can uh, introduce very basic technology for you to develop multimedia content analysis system. So if you are interested in more advanced or more detailed technologies, then you should take a machine learning course. And we will first give you a very brief overview about machine learning technology. And then we will introduce three technology that are Gaussian mixture model, hidden Markov model, and a support vector machine. And these three models or technologies have been used for decades. For decades, so uh, many important works were developed based on such machine learning models. But in recent years, a new technology emerged quickly. That is deep learning. So in the end of this semester, we will also introduce deep learning technology. So any computer program that can improve its performance at some task through experience or training can be called a learning program. So this is a very generic definition. So any program that can be learned, that can improve its performance based on experience or data can be learning program. And during early days, computer scientists developed learning program based on heuristic and insight into human reasoning mechanism. So we don't have very systematic uh, methods to develop the learning program in early days. So we just develop the program according to our domain knowledge, according to some rules or heuristic, or according to some insight observed by human. So basically, in early days, the learning program can be in the form of decision tree. So that's what you can do in in your programming language class. So you may write a program and define some rule. If x is larger than some threshold, then do something. Else, you do something. Okay. So this is the early day learning program. And the neuroscientists attempt to devise learning method by imitating the structure of human brain. So in 1980s, the neural network structure emerged, and at that time, scientists tried to develop a structure to imitate human brain. And around 1980s and the early 1990s, the neural network research field uh, are very hot. Were very hot. Was very hot, but uh, after that, uh, scientists found that there are some limitation to impede to more improve the performance of neural network. But in the early 2010, uh, in early 2010, some new technology uh, proposed, and many scientists found that the deep learning or the neural network can improve performance a lot. So let's build the thread or the recent thread of deep learning in recent years. So we will talk about the deep learning technology later. And the following slides are mostly coming from this book, Machine Learning for Multimedia Content Analysis, published in year 2007. Many learning tasks can be formulated as one of the following two problems. The first problem would be regression. The second one is classification. For regression, assume that we have input variable x, and we want to we have output variable y, and we want to infer a function f of x, so that the given value x, we will predict, we will put input the input value x, and through this function we will predict a value y. Okay, and we want to find a function such that it can infer good prediction of the true value of y, of the output variable y. Okay, so input x, we try to find a function f such that fx is a good prediction of the actual value y. So this is called the regression problem. Another problem is called classification. So assume a random variable x that would belong to one of the finite set of class, maybe class 1, class 2, or class k. So given the value x of the variable capital X, we want to infer its class label. So we want to find a function g so that we can input x, and it outputs the class label y. So y belongs to the set. And it is also of great interest to estimate the probability of probability k given x, where k is the class label. So we want to estimate. So given the input data, we want to estimate the probability of the input data belonging to different class. Okay, so in fact, both the regression and the classification problem can be formulated using the same framework. The difference between regression and the classification is that the output for classification is discrete, but the output for regression is continuous. That would be a real value, and for classification, that would be some class label defined in a finite set. So dividing the learning program into regression and the classification is one way to do to categorize machine learning problems. Another way to categorize machine learning problem is we can divide the learning model into unsupervised or supervised. For inferring the function fx or gx, if pairs of training data xi and yi or xi li are available, then we say that it's a supervised learning problem. Here means we have the input data xi and the corresponding output value or the corresponding output label. That means we have already give you the pair of input and the corresponding answer. In this way, in such kinds of problem, we call it a supervised learning problem because we already tell the program the answer or the result of the learning. And the most regression methods are supervised learning. And the unsupervised method tries to automatically partition a given data set into the predefined numbers of clusters. That is also called clustering. So for unsupervised learning problem, we just give them uh, the input data xi, xj, sk, and so on. And we don't know the correct answer, the corresponding answer, or the corresponding label of this given data point. So all we can do is just to partition the set of input data into several clusters. Okay, so that's also known as a clustering problem. So we also can view the machine learning problems from this perspective. And we also can view machine learning technologies from the generative model or discriminative model. Okay, so let's say the generative model first. The generative model compute the probability k given x by first modeling the class conditional probability as well as the class probability pk. So we can learn, we can estimate the probability by multiplying the likelihood and the prior probability. Probability k given x is actually called the posterior probability. So given the data x, we want to estimate uh, its class label or its regression value. Okay, basically class label. And this probability can be estimated by multiplying the prior probability, the probability of class k, and the probability of x given k. That means if we are known it's a class k data, then how likely a feature like x will appear. Okay, so this is called likelihood and this is called prior probability. And actually, if you have taken pattern recognition course, you may be taught this idea. And the idea, the essential concept of genetic model is that we assume uh, any image or any object or any concept, uh, we have a backend model to generate such concept or such object. For example, a flower. Why a flower can be look like this? We assume there is a backend model. Maybe the God built it. So we just tell the model some parameters, and then this model can generate a flower to us. So the task of generative modeling is that we want to estimate the parameters that build this model. Okay, so this is the concept of generative model. In contrast to generative model, we have discriminative model. Discriminative model, they don't want to model the appearance, the visual appearance of flower or tiger or apple. No, they just try to learn this probability distribution directly from the training set without attempt to modeling the observation X. So we don't care how we don't estimate the model, we don't build a model to describe the visual appearance. We just try to discriminate. Okay, this set of features is different from this set of features. So all we need to do is to discriminate different features. So this is called discriminate model. And there are many technologies belonging to generative model, like naive Bayesian network, Gaussian mixture model, and hidden Markov model. So we will introduce GMM and HMM later. And for discriminative model, we have neural network, support vector machine, SVM, maximum entropy model, conditional random field, and so on. And we will introduce SVM later. Another perspective to categorize machine learning techniques is model for simple data or model for complex data. So sometimes there are high interrelationship between different entities, and some model may be more appropriate to describe the relationship between different entities. So the complex data, like it may consist of sub-entities that are strongly related to one to another. For example, a beach scene usually composed of a blue sky on top, an ocean in the middle, and the sand beach at the bottom. And if we can model the spatial relationship between different regions, then we may more appropriately describe the beach scene. And for simple data, we may use naive-Bayes, GMM, neural network, or SVM. For complex data, we may use Bayesian network, HMM, Mesmer entropy model, conditional random field, and so on. And actually, there is no standard way to model data based on different machine learning technologies. So there is no um, there is no standard answer. So that totally depends on the application, and many tasks are still ongoing research topics. So many new machine learning technology uh, are proposed to tackle different problems until today. Okay, until today. So the final perspective to categorize machine learning technologies is model identification versus model prediction. Model identification is actually similar to generative model. Model identification is to discover an existing law of nature. So it assumes that uh, uh, all objects are generated by some backend models, and we want to discover some existing law of nature. The model identification paradigm is an ear-pose problem and is annoyed by the curse of dimensionality because there are too many parameters and it's not efficient. It's difficult to estimate so many parameters that can describe the nature, the law of nature. But as we said before, starting from early 2010, the emergence of deep learning start to break the problem mentioned here. Okay, we may have efficient way, we may have efficient hardware to estimate a large numbers of parameters. That is possible today. And the goal of model prediction is to predict events well, but not necessarily through the identification of model of events. So model prediction is more like the discriminative model mentioned above. Okay, so they try to predict event well, but not try to model, try to identify which model or try to uh, discover the existing law of nature. They don't do that.